Hey, so a friend of mine asked me to help her with a question the other day about this quad. She had a battery on it that was a 12-volt battery, and she wanted to attach a LED light to the front of it to give it a headlight. It currently does not have a headlight, and it's for a kid. And so she wanted to do some night rides with them where they drove out to the beach and then came back at night after it got dark, and that was going to require a headlight on the front. So we talked about the path. We said, well, where exactly are you going to go? And she said, well, from the KOA, which is the camp, we lead out this blue line here, and that is where the asphalt stops. And then we get into sand. And from here, it's all the path that leads out to the beach. And so they'll follow this path all the way out to the beach line over here, hang out until it gets dark, and then they'll follow back out towards camp. All right, and so this backwards path would all be in the dark. And so this is an upper plateau in this region here that drops down into a whoop road. And this whoop road around here has got a little squiggle to it, and it has wave after wave after wave of sand dunes that are like a couple feet apart. And so you're just constantly driving up and down these little bits of sand dunes over and over and over again, all the way down this road. It's exhausting, especially at night. So you got to figure out what direction you're supposed to be going on some of those, because it's not overly clear. There's going to be little dips and dives that you can take off and branch out from the main road. And so we need to have nice clear lights. The pathway back, so from the time it gets dark, we'd be at the beach, and it would take about an hour and a half. It'd take about an hour, really, to get back. So we're going to give it an hour and a half. We're going to say that's going to be our buffer zone. We know it's going to be about an hour, 45 minutes to an hour to get back to camp. So we're going to say, well, what if we want the light to stay on for an hour and a half? Right? That gives us plenty of time. On top of that, we have battery usage to be concerned with, because this bike doesn't have a clutch on it, so you can't like stop it at the top of a hill and roll it down and pop the clutch to get the motor to start back up again. You have to have a battery charge to hit that spark plug. So that is a part of this as well. And so we want to just make sure that we don't go below 1/4 of the battery, right? Because then it won't start if we're below that, too far below that quarter mark. And so that's going to be a part of the buffer zone. We want to make sure that that 3/4 of the battery can be used for the light, but we don't go below that within the time that we're looking to get back to camp. Right? And so we know that it's about an hour. If we say that we can use 3/4 in an hour and a half, that's going to be the limit, right? That's the maximum limit. And so that's our goal. We're going to try and get this to be our goal here. So on this page, we're going to look at the battery. The battery itself looks very much like your car battery. It's just a little lead acid battery. It has a maximum capacity that's a little bit less than most 12-volt batteries, just because it's a smaller rig. So it is 12 volts, though. It outputs 12 volts. And then its charge capacity here is what it's telling us about. It says its discharge current can be 40 amps total, which means that over 10 hours, we have 4 amp hours. Right? And we'll just take our 40 discharge current and divide it by the number of hours it's going to be running for, and that's going to give us the number of amps we can use per hour before we discharge completely. So we're going to use this value. We're going to use this 4 amp hours, and we're going to use this discharge table over here to visualize how long it's going to take this battery to drain on our way back. So the first thing we would look at here is the fact that this first line, this orange line at the very beginning, starts at about like 12-ish full battery charge, right? It says from the full battery, it's going to dramatically dump the charge. Within 2 minutes, this battery is going to be dead. Okay, well, we don't want something that's going to suck 40 amps then, right? How much wattage is that, though? That would be the question, because all of our lamps are going to be measured in wattage. And so let's pull a Desmos over here. Let's see, we've got 12 volts. We know that battery is going to be 12 volts, and we would multiply that by our amperage. And if they said that it was 40, in 2 minutes, a 480 watt lamp would drain this battery. We don't want that. Right? We don't want that to happen. So what if we had a 15? What if it was 15 amps? Well, that gives us 10 minutes. Right? We see that right here. It's 10 minutes only at 15 amps, and that's 180 watts. 180 watt bulb would drain this battery in 15 minutes, or in 10 minutes. If we lower this down to just 5 amps, we see that, well, that's a 60 watt bulb. A 60 watt bulb would drain this in about 30, 45 minutes, right? Somewhere in this range. That's not enough. We need more, right? We need to get up to like this range up here. And so we're going to keep going, but we don't want to just guess, right? We could guess a little bit on the safe side and get like 5-hour range, but that bulb's not going to be very bright, right? So we want to find one that's going to be a happy medium in between those two. And we can do that. We can do that using our power equation. We can say that if we find the wattage of the bulbs, we can figure out the current through each one, and then we can compare it to this chart here and figure out how much time is going to pass by. And on top of that, we also know about our battery. We know how much time actually can be held there. And so that's going to be our other factor over here. So let's look at that. We'll say that, actually, let's go on the next page. That's going to be a little more easier for us. This one, there we go. So we'll say that we have 1.5 hours drive back. We want 3/4 of the battery to be able to be used for this and then not more, right? Because that would hurt our ability to start the bike again. And that we have 4 amp hours of total charge, right? So we can use these two bottom ones together. We can say, well, we want 3/4 of 4 amp hours. Well, that's 3 amp hours, right? 3 amp hours is going to get us 3/4 of the battery's usage. Okay, so that's, now we know how much we can use. Now we need to know how long that's going to take us, right? And so we can say that we're going to be out there for 1.5 hours. So we're going to divide this by 1.5 hours, and that's going to give us amps, right? These 2 hours are going to cancel out. We're going to divide that out with a Desmos. I'll say that we have 3 divided by 1.5. 3 amp hours divided by 1.5 hours is going to give us 2 amps that we get to use per hour. All right, that's our amp hour, 2 amps per hour. So that's what our light can do. So now we just need to figure out, well, what kind of amperage do the lights actually have? And so let's look at the different light options that a friend of mine passed over here. She had, let's see here, she started off with this one. This is a nice little light, right? It has a lot of illumination on it. We see how many refractors it has in there, so it's going to have a big open net for it to cast onto. That's nice. It's going to be a high lumen light, but look at this, 72 watts. 72 watts sounds a little much, and so when we calculate that, we have no idea how it compares to this table back here, so we're going to use that 72 watts and compare it to what we know our battery is going to deliver for us. Let's move this over here. So we use our current equation for this one. We can say that, well, we'll use our power law and our current equation, because we can know that Ohm's law and the power equation can be put into a triangle, so power, voltage, and current. And that's our law, right? And so if we want power, we'll say, well, it's voltage times current. But if we want current, and we have power and voltage, we can say, well, current is equal to power over voltage. And that's going to give us that also. So we can figure out how much current this lamp is going to use. We can say that we know that it actually consumes 72 watts, and that we know that our battery would give it 12 volts. And then we can figure out our current from there. Can say that our current expected for this is going to be 72 divided by 12, 6 amps. 6 amps per hour. It's way more than 2. That's way more than what we can actually use at any point, right? Because this would drain it really, really quickly. Let's look at our chart here. 6 amps. All right, we'd be done in about 20 minutes, 30 minutes at most. Right? It's not enough. So we can't use this light. This light's a little too big for us, for this specific one. It doesn't have enough charge. This next one she gave me had a lot less lights, right? We see a tiny, tiny, tiny little ones is stuck in there also, so that's going to provide some illumination there as well. It comes in a pack of 4, so she had 2 of these that she wanted to do, so that was kind of a good deal. After that, we just need to look at the 36 watts, right? And this is a spot flood combo, so it's going to have the ability to kind of do a high beam, low beam situation where it distributes out its brightness. So 36 watts. So let's calculate that out with our 36. So instead of 72, we'll say 36 power in watts. That's going to give us 3 amps. That's a lot closer, right? It's not quite enough. It's not quite close enough, but it is closer. We could go through and calculate our power out from this. We can say, well, what if we take our equation here and flip it backwards and say that we now know that this is actually 3 amps. And we want to find the time on the bottom, and we know that we have 3 amp hours. Right? How many hours can we get out of that? Well, we can rearrange. We can multiply t to both sides and divide 3 amps to both sides. We'll have 3 amp hours divided by 3. That means we can do 1 hour. 1 hour only. That's not enough, right? It probably would be. But we want to get that buffer zone. We want to make sure we don't run out, right? We might run out of our power and then not be able to start the bike up if something goes wrong. And so we don't want to go wrong right in the middle of the night. We want to be able to make it back to camp with lights. So too much. That's too much also. It could work, but it could cause problems. So we kept looking, and we saw this one. This one has less LEDs in it, right? We only see the 6 main ones. It has less lumens, but these are high output floodlights. And so they did pretty well. They lit up a lot of the area, and they had their own cooling system on them. And they are 18 watts. Well, 18 watts sounds a lot smaller than the other ones, so we'll say, let's go here. We could probably go up to 24 watts. But I think we stuck with these ones. This one gave us 1.5 amps. That's less than what we wanted, right? We wanted 2 amps. And so now we're down to 1.5 amps. So now we can run even longer, right? Move this out of the way. This one also noted that it ran on 12 volts. It was for a golf cart, a boat, right? The off-road vehicles kind of thing. And that's really all we really needed from it. After that, it was just going to tell us that it was 6 lights at 3 watts a pop, giving it a total of 18 watts. It told us the color range, and then the lumens was the other part that we really wanted to compare. Right? Because technically we could use this other one that we saw here if we wanted those amount of lumens, if we really needed a higher lumen count. This one's only going to be like 1,500 lumens. It's going to be much, much smaller, much less. But it's going to have a similar range to it and intensity, so the focus-wise. And we're really not shooting too far out, right? We're looking pretty close by to make sure that we can navigate some of our ups and downs. So we really want something that will flood the local area really, really well. And so this is the one we actually went with because it would allow us the most amount of time, most amount of buffer time before we actually ended up hurting our quad out. So that is how you configure your battery output. Let me know if you guys have any questions or you want to talk more about this.